Welcome to your podcast for Lesson 24, Mass versus Weight. After reviewing the podcast, you should be able to explain the difference between mass and weight, define the normal force, and also describe net force. For class tomorrow, I'd like you to be able to answer the warm-up with the people in your groups. So think about when you go to the moon, what changes, your mass or your weight, and you should be able to explain why. The assignment that we'll work on tomorrow in class you see is listed at the bottom of your screen. Mass and weight are two terms that students use incorrectly all the time. They try to use them interchangeably, but it turns out that they are actually two different things. The mass of an object remains constant no matter the location. So whether you're here, whether you're on the moon, whether you're in outer space, it's always the same, and that should make sense if you remember what mass is. Mass is anything that has matter to it. Weight is different, though. Weight depends upon gravity. And so if you change your location and the force of gravity happens to be different there, then your weight is going to be different. So for example, if you go to the moon has about 1/6 of the gravity that we experience here on Earth, and therefore your weight on the moon would be 1/6 of what it is here on Earth. And so keep in mind that mass never ever changes no matter where you are, but weight will change with location because weight is simply just a force that is caused by the gravitational pull. On Earth, we know gravity is going to act on objects the same. And we know that that value is g, -10 meters per second squared. And so because on Earth that won't be affected, we can calculate the weight of an object here on Earth by using the following equation. Fw equals mg. So F, again, just meaning that weight is a force, the subscript W because we're talking about weight, because we will talk about other forces very shortly here, and that's equal to an object's mass multiplied by g. So mass times -10 meters per second squared. So if you would like to figure out what your weight is here in newtons, take your mass in kilograms and multiply that by -10 meters per second squared. Since I know that weight is a force caused by gravity, and we know that gravity acts downward on objects for our frame of reference, remember it pulls things towards the center of the Earth, I know that my force of weight is going to act downward on all objects as well. And so even though my weight is acting downwards due to gravity, I'm not going to fall through the surface of the Earth because the Earth actually pushes back up on me with a force that is equal to my weight. And that force is something that we refer to as the normal force. Okay? So normal force is any force that acts perpendicular or normal to the contact surface. And so if I am standing on the ground, okay, I know that my weight is going to be acting downward because gravity is acting down. So if I draw that, okay, with that arrow, okay, to represent the Fw, or in other words my weight, I know that the normal force is going to act perpendicular to that, and so it is going to act in the opposite direction. Okay, and we label that Fn for normal force. Notice that when I drew that, I tried to make my two arrows equal in length because when I represent vector quantities, I use arrows, and if those arrows are the same length, I know that they are the same magnitude. Okay, so this works not only for the example of the ground pushing back up on our feet, but this could also act for horizontal forces as well. So for example, if I push on the wall, okay, so here's a wall, and I am going to push on it with my hand, and we'll make this force I'm pushing on the wall. That wall, we know, is going to push back on me with the same force. Otherwise, I would fall through the wall. So when I draw this, okay, I'm going to draw my normal force, okay, going from that same point, right, in an equal magnitude, so same length, but in the opposite direction. And again, this would be my normal force, and this would be the force of my push against the wall. This leads us to the idea of net force. Net just means the sum of something. For example, if you have a job and you get a paycheck, the gross amount on your paycheck is what is there before taxes. The net amount is what you actually get to put in the piggy bank after Uncle Sam takes his share. So when we talk about net force, we're talking about the sum of all the forces acting on an object. If we tie this into the motion of an object, okay, remembering what we learned in previous lessons, if something has zero acceleration, that means that its velocity is not changing, or in other words, it has a constant velocity. If something has a constant velocity or is experiencing zero acceleration, there are no other forces acting on that object. So we say it has a zero net force. Okay. This is also true for an object that's in a state of rest. To be in a state of rest, it's probably sitting on something, either the ground, the surface of a table, the surface of the road, and so we know that weight is going to be acting down on that object, but the normal force is equal and opposite to that, coming up out of that surface, perpendicular to that surface. And so again, state of rest means that we're going to have a net force of zero. Okay. If something is moving in a straight line at a constant speed, okay, so constant speed, straight line, no acceleration, so again, I know that that net force is going to be zero. Okay. If I want to change the motion of an object, I need to apply a net force on it. Remember Newton's first law of motion. An object at rest will stay at rest unless it's acted upon by an outside force, or an object in motion will remain in motion in a straight line in a constant speed until it's acted upon by another force. And so a net force is going to cause an object to either speed up, slow down, or change directions. And remember, those three things: change velocity or cause acceleration. So net force causes objects to accelerate. So take a look at this concept question and see if you can come up with an answer for class tomorrow. Next concept question, I'd like you to solve for the weight of a person which has a mass of 70 kilograms. Next concept question, what is the net force acting on a person that has a mass of 70 kilograms when that person is standing on the ground? What is the normal force acting on a 70 kilogram person when standing on the ground? Alright, this one's a little bit trickier. What is the normal force acting on a 70 kilogram person in free fall after jumping out of an airplane? And also, what is the net force acting on him? And finally, what is the net force acting on a 70 kilogram person jogging at a constant speed of 3 meters per second?